Hello, my name is Dylan Early, and I am in my sophomore year at Trine University. I am majoring in mechanical engineering. For my first semester this year, I am taking the class Engineering Materials. For this class, we were able to select a material that we found interesting at the beginning of the year, and we would apply the things learned in class to that material and make a video at the end of the year showing how that material applied to what we learned. After tough consideration of what material to choose, I selected carbon fiber. We began the semester talking about stress-strain curves in class. What exactly is a stress-strain curve? A stress-strain curve is a graph which displays the correlation between the stress and strain of the particular material. As you can see, the graph on the top right is the tensile stress-strain curve of carbon fiber with different weight percentages added to it and how the material reacted to it, while the bottom one is carbon fiber's response to a variation in tensile properties. We then began to learn in class about how mechanical properties of materials and how they are related to the selected material. This involved the modulus of elasticity, shear modulus, yield strength, tensile strength, how rigid the material is, resilience, toughness, hardness, the price per kilogram, and the density. After spending time in class learning about these different categories, I did research about carbon fiber to find out what it was in terms of these properties. I found online that the modulus of elasticity for carbon fiber is 228 gigapascals or 333 MSI. When researching the shear modulus for carbon fiber, I found many different values that varied, but the most consistent value I found was 0.6 MSI. I was then able to find both the yield strength and tensile strength of carbon fiber. The yield strength is 470 megapascals or 68 KSI, while the tensile strength is about 300 KSI. While doing research, I learned about how rigid and if carbon fiber is a brittle material. Carbon fiber is 4 times stiffer than plastic, 20 times stiffer than pine, and 2.5 times stiffer than aluminum. I was then able to find out how resilience worked for carbon fiber materials. When looking at carbon fiber, the blades of it specifically, they can find out how resilience works. They are much longer than most fibers of models. This means that they are more resilient at sea and more efficient in less breezy conditions. I then did research about the toughness and hardness of carbon fiber. I found out that the toughness of carbon fiber is about 1,000 megajoules per meter cubed. When looking at it in terms of hardness, despite being a very lightweight material, it has a greater hardness per unit of weight when compared to glass fiber composites. In terms of mechanical engineering, carbon fiber is a material that is used all over the world for many reasons. It is used for certain things like wind turbine the blades, parts on cars, spaceships/planes, sporting good equipment, mechanical equipment, and medical equipment. When looking at the price of carbon fiber, it typically costs around $22 per kilogram. And when looking at it in terms of its density, it is about 1.55 grams per centimeter cubed. After we learned about the different mechanical properties of materials, we moved on to learn about the crystal structure and unit cells of materials. After learning this, I went and did my research on my own to find out more about carbon fiber. After doing the research, I found out that the melting point is 3,367 degrees Celsius, while the boiling point is 4,827 degrees. I was then able to find out that carbon fiber is composed of different types of fibers between the diameter of 10 to 50 micrometers that are mainly conformed of carbon atoms. I also researched about the unit cells. The unit cells are modeled as transversely isotropic materials. They also have 8 atoms in each corner, 6 in the face, 4 internal carbon atoms in the body as well. The radius of these unit cells typically are around like 2.5 and 5 micrometers. The top right image are scanning electron microscopic images of carbon fiber, while the bottom right image are a couple examples of the unit cell of carbon fiber, giving you different visuals of carbon fiber that you may have not seen before. We then moved on and learned about different types of failure, corrosion, and degradation of materials. After learning about these in class, I went and did more research to understand what failures or corrosion take place in carbon fiber. The main failure that occurs in carbon fiber is matrix cracking. Matrix cracking is damage that is found in a large number of composites, leading to changes in the mechanical property of that material. After that occurs, it will progressively get worse over time as more forces or loads are applied on that same piece or area. Something else I learned is that interface failure and fiber breakage will occur as well, but this doesn't occur in carbon fiber until it sees about 80 decibels of amplitude. Corrosion can also occur in carbon fiber in terms of Galvant corrosion. This can only occur when two electrochemically different metals are close to one another while being submerged in an electronic liquid. An example of this liquid would be like salt water. We also learned about degradation of materials. When looking at carbon fiber in terms of degradation, that's not a thing. That can't happen to them, and it'll virtually last forever, but it's still able to maintain cracks, breaks, or no longer be fit to use. These are some of the citations I have used, and I've learned a lot of things this semester that makes me look at the world much differently. Never before did I pay attention to what materials we use for certain things, but now I understand why it is important to understand materials as an engineer, because I will be around this for the rest of my life, and I hope I can expand my knowledge not only on carbon fiber, but also other materials. Thank you. Are there any questions?